Hi, everybody. Welcome to today's Tech Talk, Accelerate Analytics and Machine Learning in the Hybrid Cloud Era. In today's talk, our speakers will be walking through what Alluxio's data orchestration system is for the hybrid cloud era and how it solves the performance and data management challenges that we see. My name is Amelia, and I will be your moderator. Before I introduce you to our speakers, I have just a few housekeeping items. All participants are automatically on mute throughout the session. We will be using Slack to communicate, so please take a moment to join us on the community Slack channel, which is copied into the chat box and can also be reached at alluxio.io/Slack. However, if you are having trouble joining Slack, you're welcome to message me your questions instead, just via the GoToWebinar control panel located on the right-hand side of your screen. So in today's session, you will be hearing from two speakers, and then we will have a Q&A session at the end so we can answer all of your questions. And again, to ask a question, you're welcome to join the community Slack channel or to send me your questions via the GoToWebinar control panel. And please don't hesitate to send in your questions anytime. No need to wait till the end. Lastly, today's session is being recorded and will be available for on-demand playback. We will email you the link to the presentation as well. So that's it with the housekeeping items. Let's meet our speakers. I'm very pleased to welcome Peter Behrakis, who's the Director of Sales at Alluxio. He will be talking about the trends and introducing Alluxio and the need for data orchestration, followed by Alex Ma, who's our Director of Solutions Engineering. And Alex will be going into Alluxio, how it works, as well as covering some use cases. So without further ado, passing it on to you, Peter.
Thank you, Amelia, and good day to everyone joining us. Hopefully it's a fine day where you are. Let's move to the agenda slide and get into more detail about what we're going to talk about today. Well, first we're going to talk about market. We're going to talk about the Alluxio vision. And then we're going to get into use cases and details. And then we're going to have a Q&A session as Amelia brought up. I'm not seeing our slides advance. Can anybody help me with that?
Yeah, apologies for that. Alex, are you able to advance the slides? Okay, just give us a second as we reset our slides.
There we go.
There we go.
Well, the anticipation was just incredible. So we're going to go through market, Alluxio's vision, and I think, you know, right tool, right job. I think there's a little bit of that to be said around the Alluxio vision and what we anticipated that's now occurring in the market. And then what is data orchestration? What does it mean in the big data world that we live in? And then, you know, hopefully after this, we'll have a Q&A on how we might be able to help you with some of the questions you'll bring up. So what we see in calling on Fortune 2000 companies is there's data everywhere. Some of it's through acquisition, some of it's just organic. They start out with the data warehouse, then they got Hadoop to be the data lake, then they exercise the connectors from the data warehouses into Hadoop. And Hadoop was really supposed to be the big data platform for doing broad-based analytics and to some degree machine learning. But it's been very, very hard for companies to get all the data into Hadoop, or they have multiple versions of Hadoop, different sites of Hadoop. And while you know, they're trying to consolidate data, which is a lot of work, it really is an impossible task to get all the data in one place through normal business operations, to have all that data to be available for the analytics that the business is demanding. And what we're hearing from executives, you know, we were just on in a meeting last week with a Fortune 500 telecom company, and their mission, they've got, you know, multiple Hadoop clusters, probably 3,000 or 4,000 nodes, tens of petabytes across multiple locations, lots of lines of businesses. And they, you know, their mission is to start to separate compute and storage. I think they've seen that Hadoop has been great, but, you know, after all the tuning and using all the newest information on how to tune and segregate data and use cases on Hadoop, I think they're just realizing that compute and storage needs to be separated, or it's already being separated because of the need to use cloud, which takes me to the next column. People are naturally having data spread and data sprawl in their organizations because line of business has the money to do it, because it makes sense to burst to a cloud, because they have multiple data centers. You know, all of this is just separating compute and storage, and that's creating an issue because much of the analytics that's now been established is ingrained in a mandatory part of the business operation for the companies we call on. And if anything, it needs to be faster, and it needs to have lower overhead to deliver the types of information they need to run their business. With this, we're seeing the rise of the object store. We all have known about object stores for years, and clearly object is in the cloud, but people are starting to rethink object as an extension of their data lake on premises. So now it's maybe I can start to drain my Hadoop cluster. It may help with performance, but I just need to get data off into a different type of data storage that's a little bit more scalable. And as many people know, much of the machine types of information that's being thrown off is in object and or S3 form, and not so much in file and in structured data as it was in the past. So this is really a good fit for having an on-premises object store that's something more than just you know, a cheap and deep archive. The other things we learned from our customers are they really want the line of business, the business analyst who's in research, or the business analyst who's working on, you know, driverless, you know, autonomous driving, you know, wherever it might be, or fraud detection. They really want them to just do their job and not even know where the data and where the compute really is. That's what the IT executive and the platform and research executives want for their community of thousands of people at companies, typically, to kind of experience, as opposed to waiting for data engineering to move the data into place or to copy it into the right place and then sync it before they can run their analytic jobs, right, in their data pipelines. Just a summary. So, you know, it's always been the same. The volume, velocity, and variety are avalanching, and data is doubling every 2 years if you read the Fourth Industrial Revolution by Klaus Schwab. The business knows analytics are needed. Machine learning is needed. They're depending on it from the whole Hadoop and big data era. And now more than ever, they want it to be faster, quicker, and less overhead. They'd love a self-service model if they could get it. So the demand is going up while all the data, even the data is still coming at us and our customers in a very, very high velocity way. Object, we're hearing, might be the new data lake to a large degree, and companies are wondering, can I get the same type of performance I was getting on Hadoop on running some of these same use cases on an object store on premises? And the enterprise really is multi-cloud or hybrid cloud, and will be for some period of time. I mean, every company we call on, I mean every one, they're doing something in the cloud, whether it's an experimental way or it's in a big way, or they've gone all in the cloud. But typically they're using, we find companies have some on-premises data and storage and compute, and they have it in the cloud as well. The technical leadership, as I mentioned a moment ago, whether it's in the line of business as a research executive or it's in IT or as a platform, you know, they all want to be able to run their applications anywhere and be unencumbered by moving data all around and copy and sync, and the big data engineering burden that typically it puts on companies, because they have to be agile to the business, and if they aren't, they'll be less competitive. And clearly they want that self-service where the ultimate analytics user in this case, or big data user, or machine learning, or data scientist, doesn't necessarily have to care where the compute and storage is. That's where people are going. And clearly, technical organizations are struggling to keep up with the data ingest and business demands. You know, all of the above is very, very challenging for folks. So what's Alluxio's vision? You know, we saw that compute and storage would start to separate some years ago, and this is probably 7 years ago now. And for us, it's orchestrate data for analytics and machine learning to enable companies to grow and be agile regardless of where their data and compute are located. I mean, this is a pretty big idea. You know, back 7 years ago, people were really still loading up Hadoop, and that whole analytics, compute, and storage were in one data stack, typically in one data center. It technically wasn't a problem then. But our founder foresaw that that would probably change over time because of a variety of things. New compute frameworks coming out every 5 to 7 years, new storage types of technologies coming out, the adoption of cloud, et cetera. So, you know, our vision is we can get somebody to use, if we can get somebody to use Alluxio, they can quickly get a multi-data center and or cloud, hybrid cloud environment up and running and see 2 to 5x analytics acceleration for things that are time sensitive, right? Fraud detection, right? Research treatments for diseases, uptime for all industrial and digital technologies that we all depend on, like traffic lights or whatever, right? So the notion of being able to do things faster with the same infrastructure is really the goal of the company. And we believe everybody, if you've got 500 nodes of Hadoop or more, and you know, even as little as 5 to 10 petabytes of data, our guess is you will have 1 or 2 use cases at least that probably could benefit from A, faster results, and or B, just much less overhead to maintain the analytics pipeline. So, data orchestration in its pure definitional form, a platform that brings your data closer to your compute across clusters, regions, and clouds. It's all about data locality. That's one of the key things we do, is we are very fine-grained in our ability to pull just the job data that's needed and pull it close to the compute, put it in our cache, and optimize the performance of those jobs, and then place it back wherever it came from, that particular data, or use intelligent tiering to place it somewhere else if that's the intent of a company. So why do customers use Alluxio? We typically give them faster results. That's really what it is. And why would they use us? They'd use us because they care about getting faster results in those 1 or 2 use cases that I mentioned. What do we see compared to not having Alluxio involved? If it's between computers in one place and in a data center, and most of the content or storage is in another data center. If you have on-prem and you have cloud data and or compute separated, we see a 2 to 5 and sometimes greater acceleration in that workflow. So A, there's faster results, but if you're doing things quicker, especially in the cloud, your compute costs are less. You know, all the costs associated with the cloud egress costs are less. And the other big thing that it does, and you'll see when we talk about our API and driver translations we do to enable all of this, is we give companies agility. They could be running a Spark job on Hadoop in a data center today. If Alluxio is implemented, that Spark job would talk to Alluxio, that would talk to that Hadoop cluster in that data center, but it could also talk to S3 storage in another data center, or data that's located in a cloud or clouds. So that agility to be able to use the same infrastructure people have today, typically on a Hadoop environment or in a file environment, and be able to not have to reprogram that application, yet use a different underlying infrastructure with doing nothing by implementing Alluxio, is a big, big win for companies. And we've got companies today who use this, for instance, for a hybrid cloud. They're bursting compute to the cloud, let's say, and data's on-prem. They're also thinking, well, the data on-prem, maybe I don't want it on Hadoop anymore. Maybe I want it on an S3 on-premises object store. And they can move some or all of that data, if they want, from Hadoop to that object store and not have to reprogram that application. That means they can implement this far sooner than they would otherwise. We do, depending on how people are using us with the cloud, we can drop egress costs from the cloud dramatically, which could be a big savings. And if nothing else, we can assure you that you'll be out of the data movement, data syncing, data copying business, because Alluxio manages that automatically for you. And if that's a burden to your organization in keeping some of these analytic workflows rolling the way they need to roll, I think you probably want to talk to us. Typically, bullet 3 is important to people, but bullet 1 resonates. But it's usually bullet 1 and bullet 3 on this particular slide that are the 2 top reasons why people want to talk to us. And clearly, we have to drop into your environment, without any big effort or reprogramming. So you'll find we're a Linux application basically that runs on any instance you would have. So it's a pretty easy implementation. We've been in the market for 5+ years. So we have hundreds of production customers across a number of verticals who all experience those 1 or 2 use cases or more that they decided they need to accelerate, and they couldn't really accelerate on their own effectively, or they wanted to drop the big burden of the data admin and engineering costs. So from some of the biggest internet companies to some of the biggest technology companies to some of the biggest retail companies, life sciences companies with GSK, big financial organizations, we're doing a number of the use cases you're going to hear about with them, and they're seeing great results. So at this point in time, I'm going to pass it off to Alex. He'll take over for some of the use cases and the technical deep dive on what Alluxio is and can do. Thank you so much for paying attention.
Hey, thanks, Peter. So let's get it right into it. So we'll talk about some of the common ways that Alluxio is used, and then we'll dive into maybe a few more specific examples as we go on. So I think the first very common way that Alluxio gets used is accelerating big data frameworks on the public cloud. And so we have a number of users that will leverage Alluxio in an EMR or a Dataproc environment in AWS or Google Cloud respectively, and use that to accelerate against a data lake that they might have on S3 or Google Cloud Store. And there's a few different reasons for this. One, an object store like S3 or Google Cloud, is fundamentally a bit different than something like HDFS in terms of some of its operations. And so Alluxio can add some benefit in that respect regarding some of the metadata operations that are very common, when you're doing a Spark job or a Presto query against an object store. Alluxio adds kind of data locality for these operations. And so one of the things that we see is sometimes a speed up of these workloads, depending on the nature of them. Lastly, the thing that is not, too widely known, but is also really interesting is that, Alluxio can help a lot with cost around API access to, some of these object stores. And so we'll go into it. Actually, no, I think we'll just touch on it now. A third of the cost from S3 actually comes from the number of RPC calls that you do to it. And so that's something that's, maybe not as obvious, because the first 2 components, the amount of data that you're storing and the storage class of the data, those are the 2 most obvious reasons for, what determines S3 cost. But the third component actually comes from RPC calls. And so we've actually seen with something like a Presto, when you're doing a query against a large catalog or a large table, you can see sometimes upwards of 100,000 RPC calls being done per query to the underlying storage. Alluxio can help cache all of that, and in some cases drastically reduce the bill for S3. So something worth looking into. This slide built out really fast. So the main area of focus that we're going to look at today is how Alluxio can be used to burst big data workloads in a hybrid cloud configuration. And as Peter touched on, a hybrid configuration is really one in which the compute and the storage are segregated. Now, sometimes this will be within a data center. You might be running HDFS on a set of nodes, and you might be running a number of a discrete cluster of Apache Spark or TensorFlow or what have you. Sometimes these will be in the different sites, but not in the cloud. And so you might have two data centers, and for whatever reason, you have capacity in one of these data centers and data in the other. And you have a need to run this workload, and this workload is not useful without data. And so that workload may stretch across data centers to reach that. And in the last scenario, you may be running a hybrid environment where part of your configuration lies in the cloud. And so in some cases, in most cases, it'll be the compute framework. You may be renting, GPU machines on AWS to run machine learning training. You may be, bursting compute for things like Presto, so that you can run your end of quarter, ad hoc analytics or ad hoc queries against the data lake that you have on premise. Or, you may have flipped it around and have decided, hey, we've got a ton of compute in-house that's idle that can be used, but we want to really leverage, something like S3 for all of our data. And so being able to kind of burst those workloads, in a hybrid configuration is something that's a fairly common use case for Alluxio and something that we'll spend some time on today. The last common use case for Alluxio is dramatically speeding up big data on object stores on premise. So that's a mouthful, but what we see just as a typical trend from a lot of the users or customers that we talk with is a general desire to evaluate options that are different than an HDFS or traditional HDFS data lake. And so we have users that are looking at any number of different things. They're looking at open source solutions like Ceph and MinIO. They're looking at, more enterprise solutions like maybe a CleverSafe or an Isilon. Regardless, the thing that these things have in common is that they're typically not meant for big data workloads. They're not meant for, operations against Spark or Presto. They're typically designed for, maybe backup and archival workloads where cost per gigabyte or cost per terabyte is, the most important factor. And so one of the things that we have found is that Alluxio sitting as a layer with a big data framework can dramatically help to speed up that object store and provide similar performance to what they see with the traditional HDFS data lake, but without some of the cost and complexity that might be associated with it, which is one of the factors for people evaluating other options. So 3 common use cases for Alluxio and how it is used. Now, in terms of hybrid cloud or hybrid configuration, this is kind of a little bit of some of the patterns for how people go about running one of these configurations and some of the typical challenges that may come up when they try these approaches. And so these are really simple. If you're running a hybrid configuration, again, one where the compute is separate from the storage, maybe in a different data center, maybe, partly in a data center, partly in a cloud, these are the things that we commonly see. And so things like lifting and shifting the entire workload, copying data by the workload, or setting up some kind of caching framework for the workload, these are the most common ways we see people, leveraging compute resources in a separate location. Now, you can take a look and you'll see, I think we'll send these slides out a little later today, but there are some very common things that come up once you start looking into one of these. And the lift and shift, this one's probably the simplest. What we've found is that there are a lot of things going on in a modern data lake. And so the number of things that access a given piece of data, the number of things that touch a given piece of data in terms of, pipelines or ETLs or ad hoc reporting or what have you, it can take a very long time to find all the things that are impacted if this piece of data is just kind of lifted up out of the data lake and put into the cloud. And so it makes it challenging to, get all of those processes, all of those workflows migrated as well if you're doing a lift and shift. If you're copying specific data by the workload, some of the lift and shift stuff still applies. But more specifically, I think one of the things that we see is that, it's not always easy to identify what pieces of the data are the most relevant for a given workload. And I'll give you an example. If you're talking about ad hoc queries, and maybe you've got your catalogs and your tables partitioned by day, that's like the best case scenario, right? Because it's very easy to identify, hey, within this table, these are the partitions that are, they make up the last month's worth of data, and it's very easy to identify, right? It can be difficult for other workloads that aren't so logically organized by date or aren't as easily identifiable. And in those cases, one of the things that we find is, the data engineering team is sitting there going, well, okay, I'm going to copy all this data up into the cloud for you. What do you want me to copy? And when that can't be identified easily, what we're talking about is making a full copy of the data. And the other thing that we've identified is that, after people start using Alluxio, they see that, they've got access to the entire data set, but anywhere from 1 to 10% of it is the stuff that's, commonly used. And so that can add to the cost in terms of copying over that data. It can add to the network overhead. It can add to the storage costs for having a lot of data that's not necessarily going to be useful for these workloads in the cloud that you're copying there because, you don't know if it's needed or not. And then the last thing is around compute caching of the data. And this is less helpful for some specific workloads, things like ETLs, things like conversions. There are a number of things that will benefit, obviously, from caching, but it doesn't help with the whole story or with syncing this data back down with the local data lake, after some work's been done. So a couple different approaches to getting to a hybrid cloud configuration, a couple different challenges. So if we take a look at Alluxio in a hybrid cloud and how it typically ends up manifesting in terms of a journey for a customer, it usually starts with something like this. So it starts out with a HDFS data lake that is bound in some way on something, right? And so HDFS with its architecture, it ends up being kind of monolithically scaled out. And what that really means is, you've got a certain size node that you're adding in as a data node, and you're adding more of those nodes in to get additional capacity. Now, those nodes are, kind of fixed in size. So, whether you've got 32 cores or 64 cores, a terabyte of space or 32 terabytes of space, you're looking at kind of the same configuration across. And what we typically see is that the HDFS cluster is generally going to be, compute bound, IO bound, or storage bound, and it's going to be over provisioned in some capacity. And because it's under provisioned in one capacity or bound on that capacity, workloads tend to slow, which leads to kind of a poor customer experience for those that are accessing the data lake or running workloads on that data lake. So, any CTO will want to leverage the public cloud. But the challenges that come up are pretty simple. The basic challenges around moving large amounts of data. And so being able to do a configuration that spans from the cloud to the data center can get a little bit expensive. You may get a direct connect, a 40 gig or 100 gig direct connect between sites, but that can be very expensive, right? And that bandwidth can be used up very quickly depending on what your users are doing. If they're doing lots of ad hoc queries, with each query looking at a large chunk of data, you can consume that pipe very quickly. Additionally, the latency for that may make the latency for the overall query itself, not feasible. Copying data to the cloud is typically what people run into next, which is what we covered, in the prior slide, some of those challenges. And so what usually ends up happening is that Alluxio ends up being used as a solution to provide data locality for these cloud workloads. So you may be running Spark, Presto, Hive, TensorFlow, any number of other things that Alluxio supports, and running these in the cloud with Alluxio installed co-located with those frameworks. Now, Alluxio, what it ends up doing is it does a couple things. One, it abstracts access to the, to the HDFS data lake that we're talking to, and it helps to provide data locality for that data. And it does it by essentially accessing data and caching it at the request of that compute framework. And so what ends up happening because of that is we end up caching the working set of the data, not necessarily the full catalog or the full data lake itself. And this does two things. One, it provides performance for these applications like they were accessing data locally, because essentially they are. They're able to do their queries or their conversions or whatever it is against data that's cached locally in an Alluxio tier that lives in the cloud with them. The second benefit that it provides is that it's able to immediately start providing relief for that on-premise data lake. Both compute and both I/O are offloaded so that you can start providing better quality of service for the other workloads that are still running local in the data center. The last thing to mention is that we actually offer a migration policy for data itself. And this is a really interesting thing. We call it policy-driven data migration. And essentially what it is it allows you to define a path and rules on that path. And an example rule might be, hey, if this data hasn't been touched within the last 6 months, I want you to move it over to this location. Or if this data has been accessed, in the last 7 days, I want you to move it to this location. And people are finding this as a very interesting way to move archival data off of HDFS data lakes onto on-premise object stores, or even to move between S3 storage tiers, moving between the hot tiers and the glacier tiers. And what they're finding is that it reduces the manual overhead of needing to, maybe manually run Spark jobs or manually running disk CPs from their data engineering team. Instead, they can define a set of rules along a given path and have Alluxio take care of it for them. So one other option for you. So let's take a look at a couple examples of what this manifests in, if we're talking about a real workload. So the first one we'll talk about is Walmart. And Walmart's a really interesting one. They're actually using Alluxio and Presto in Google Cloud, and they're using it to provide a self-service ad hoc querying layer for something like 3,200 analysts in 200 different business unit groups to be able to do SQL queries against, a number of different HDFS data lakes. Now, as you might imagine, it is a little bit tricky when you're talking about connecting to multiple HDFS data lakes. For each of them, you have to specify, the configuration for HDFS itself, things like the core side and HDFS side XML, and it makes it a little bit challenging for different applications. And with Alluxio helps abstract all of that. What we're able to do is we're able to automatically mount all of these different data lakes, maintain access to them in a secure way, leveraging things like Ranger and Kerberos, and provide seamless, transparent access for Presto through Alluxio to all of these data. Because Alluxio is working as a caching layer in this environment, what they see is an increase in performance and an increase in concurrency. And this is great. because essentially what you're able to do is you're able to serve more users in a faster amount of time. And what they found is that the combination of the two has been a very good solution for them in servicing their users. Adobe is doing something similar but different, right? Adobe is actually spread out across 2 different data centers, with their primary data lake being in one site, and a number of available compute resources available in another site. And they're left with the situation where they can run this thing remote across a 100 gig link, but that's going to chew up a lot of very valuable bandwidth. Or they can use something like Alluxio to cache the data lake itself within the new data center and start seeing benefits. And these are some times that we saw from early on in their evaluation, looking at the differences between Spark SQL or Presto, and what performance looks like across site with and without Alexio. And what this is manifested in is a solution that allows them to service their end users and do so with kind of a scalable architecture, because now they're no longer necessarily bound to what kind of capacity they have within a given site, and they can run a hybrid configuration to scale out these workloads as their analyst headcount grows. Okay. EA, Electronic Arts, is another really interesting use case. This one's a little bit different. This one is all in cloud. And for this, what they are doing is they're running Presto on EMR, accessing data on their S3 data lake. And so one of the things they found is that they can use Alluxio to essentially optimize the Presto configuration. And it does this in a couple different ways. It does it, one, by aligning the data access to the storage. We'll look at that feature in a little bit. It does it by providing elastic scale so that Alluxio can grow and shrink with this Presto cluster on demand and help to reduce some of their costs. And lastly, it helps by caching many of the S3 metadata operations so that Presto can request that, it can be serviced by Alluxio, and they can dramatically reduce 30% essentially of their S3 costs. And so we'll look at some of these features in a little bit. Okay. So there are really a few key innovations within Alluxio that allow us to provide all these benefits. And what it really is, or what it really comes down to, is I think the parts are greater than the sum. I forget exactly how that quote goes, but these 3 simple things provide something that's a lot more powerful than these things are individually. And so what they really are things like unified namespace, API translation, intelligent caching, and multi-tiering. And so we'll look at what each of these mean in depth. In terms of data accessibility, that's the simple concept that you have all of these different compute frameworks, and the list is just growing in terms of the number of things that you might ask questions with of big data, right? And so the 2 most popular ones that we work with right now are probably Presto and Spark, with TensorFlow as a close third, right? But all of these different things are things that you would expect to see in any big data environment. And soon you'll see additional things. All of these things would like to talk to data, but some data is constantly changing, right? And so if you look at the bottom of this graph, you'll see HDFS, but you'll also see a number of different cloud object stores, a number of open source object stores, and a number of enterprise style object stores. And one of the simple things about this is that we notice teams, they've written their their data access layer to go against a specific object store, or to go against a specific POSIX file system, or to go against a specific HDFS cluster. And they may have a legacy application that's critical to them that they don't want to take the time to rewrite all of this stuff, to accommodate their new, storage strategy. And so what Alluxio does is it actually works by, connecting all of these things and providing API translation and seamless access to all of these. And so really what that means is, Presto and Spark and TensorFlow can easily connect to any of these things down on the bottom. If you've got an application that's built, that's, historically talked to HDFS, and now your strategy is to move to, min.io or something like that for object store, you can actually seamlessly insert Alluxio into there. The application does not need to change, and we can actually seamlessly route all of those calls that used to go to HDFS to an S3 without having to make any kind of, code change at the application level. So a lot of really interesting capabilities with that. Data locality with intelligent multi-tiering. This is probably the thing that Alluxio is most known for, providing data locality for applications. And data locality just means, hey, instead of reaching out to this HDFS cluster or this object store, set aside some of the local resource on this machine that is, available, and use that for Alluxio to provide a data storage tier. Now, it's very flexible in terms of what you might configure. You might configure memory or SSD or spinning disk, whatever it is that makes sense. We have some customers that are caching petabytes of data. We have some that are caching hundreds of gigabytes, right? And so depending on what you use, your priorities between data size, latency, speed, and other constraints that these application frameworks might be bound on, it can determine what makes the most sense. And so data locality is one very important feature that Alluxio provides, but that data locality also works the other way as well. And so we talked earlier about the PDM feature. We'll go into a little bit more in just a bit. But that intelligent multi-tiering can be used on both sides of the equation, on the storage side as well as the compute side. Activesync is actually a pretty critical feature, especially when you're talking to an HDFS data lake. I think of Activesync as being able to tie into a write journal or a write-ahead log, if you will, of what's going on with the HDFS data lake. It ties into a HDFS mechanism called iNotify that essentially allows us to become aware of all the mutations that are happening on the HDFS data lake, and that allows Alluxio to stay in sync with the changes that are going on and know if we have the current data or if that data is out of date and we need to fetch a fresh copy of it on demand. Here's an example of the policy-driven data migration and Alluxio's unified namespace. So the unified namespace concept is really simple. It is the concept that Alluxio provides a single unified file system hierarchy to your big data application, but that file system hierarchy might be composed of multiple physical file systems, right? So in this case, in this diagram, what we're looking at is 3 logical file systems, 2 different HDFS data lakes, and an S3 data lake that are mounted and presented to the application through this framework. And so it's fairly simple. You can kind of walk through it visually yourself. I think the only thing that's interesting about this is that you can see that there's one HDFS data lake and one S3 bucket that are mounted at the same point. They're mounted on /data. And this is what we call a union mount point. And when you have a union mount point, you can actually specify policies against it. And so this might be perfect in the case where you have a HDFS cluster, maybe it's got several 100 million files on it, and you're trying to offload some of those files that are now archival so that you can relieve some of the pressure from your name node. And this is a common case that we have where, this is exactly what happens, and they want to be able to take data that hasn't been accessed in a while offloaded to archival S3. And so in Alluxio, you can actually configure rules such that you can define the exact time, the exact path, what should happen to the data, if it should get copied or if it should get moved completely. And you can actually set that kind of thing up and have it run automatically for you. In terms of a reference architecture for Alluxio, what does this thing look like? It actually looks a lot like HDFS in terms of the general architecture. Instead of a name node, you have the Alexio master. Instead of a data node, you have Alluxio workers. The only thing where this starts differing is where you might have these big data compute applications like Presto and Spark. And so what will happen in a typical deployment is you'll install Alluxio workers alongside those frameworks. And those frameworks will use an Alluxio client library to go and talk to an Alluxio cluster. Very similar to, the HDFS client jars, right? And so very similar in terms of the control and the data path as well to HDFS. Spark or Presto will make a request for a piece of data. The Alluxio client will talk to the Alluxio master to see where that lives within the cluster. If it lives locally in the cluster, it can be serviced. If it doesn't, the closest Alluxio worker can be directed to fetch that from wherever it lives, whether it lives, in a HDFS data lake or an S3 data lake, cache it locally, and then service the request back to, the requesting application. So fairly similar in terms of architecture to Hadoop. We've obviously learned some lessons from the Hadoop architecture in terms of how to scale the name node of the Alluxio master. And so we do some interesting things so that we're able to work with a very, very large number of files in our namespace. The Luxio Catalog service is a fairly new feature. And what it's designed to do is provide an abstraction layer for things that will look like databases as opposed to files. And so it does a few different things. I think the first thing is maybe around schema-aware optimizations, and we'll look into what that means in just a little bit. And the second thing is that it really just simplifies the deployment of Alluxio in a production environment. What it's able to do is tap into a metastore like Glue or Hive and allow you to start using Alluxio without any kind of change in a very short manner. In terms of some of these schema-aware optimizations, one of them is around compute optimizing the storage format. Now, we can do this in actually two different ways, and EA, as an example, leverages both of these. But oftentimes, the data source format will be things like Parquet files, or they'll be CSV files. And so in the case of Parquet files, one of the things that we've noticed working with Presto users is that Presto works much more efficiently against a smaller number of large files compared to a larger number of small files. And so what Alluxio can do is it can help automatically coalesce these files to optimize the performance of something like Presto. The other thing that it can help with is it can help with format conversion. And so this is really, CSV is not like the most optimal format for storing something for ad hoc queries, just because it intensifies the amount of read IO that must be done to service a query. Whereas converting to something like Parquet, where it's a columnar format, it's much more optimized, both from an IO perspective as well as a latency perspective to service a lot of these queries that are done in the big data workloads. And so without, again, having to run an extra Spark ETL conversion job, Alluxio can actually handle that for you as well. And so as an example of, what that looks like, what we're able to do, I think these results are actually from EA, is attach an existing Hive metastore into the Luxio catalog so that your application can start leveraging Alluxio and all the benefits that we walk through kind of immediately without much work. Alluxio catalog serves the metadata to Presto, and then we both coalesce and convert their storage of CSV into Parquet. And so this is what it looks like originally, in the original configuration. This is a small query, obviously. This is Presto going against a large number of CSV files. After Alluxio has transformed these CSV files into Parquet, you're looking at, a query that's running much faster. And after Alluxio has cached this data, you see, again, this is being done, again, even faster. So just a quick example of some of the optimizations that you might see for Alluxio. So, that was a high-level overview of, some of the common use cases that we see for Alluxio, kind of what hybrid cloud configurations are, and some of how Alluxio actually goes about doing, some of these operations and why it is able to offer some of the benefits it has. So let's take a break now and see if there are any questions. Amelia, maybe you can lead us off.
Thanks, Alex, Peter. Great presentation. We have a lot of questions here. So the first one, let's start off with, is how does Alluxio work with Kubernetes?
Great question. So, Kubernetes is a pretty obviously popular deployment and provisioning mechanism and just abstraction mechanism that we see, probably a good portion of our customers using. And so with Kubernetes, Alluxio provides a couple different things. One is obviously a container image so that you can actually deploy Alluxio in a container. Instructions for how to tie it into maybe a Spark container or a Presto container so that you can do some of these things if you like. And then in terms of provisioning, we also tie in with the common ways that you might provision a service in Kubernetes, whether that's through kube control or whether that's through Helm. You can actually deploy Alluxio alongside your big data applications in a containerized environment. And that's proved to be really popular, in internal cloud platforms, as well as, in, just general major cloud platforms, because of the portability that it provides and the flexibility in terms of provisioning, management, and resource utilization. So your Alluxio is definitely able to work with a containerized environment, specifically Kubernetes, and we actually have a few presentations on our site that kind of walk through the best practices for how to go about doing so.
Great, thanks, Alex. We got a couple of questions here about whether Alluxio is a software-only solution, if it includes dedicated hardware, and whether you have to build sort of infrastructure in order to leverage Alluxio. So maybe you can talk a little bit about that.
Sure. Just to touch on that quickly, it is a software solution. So, the infrastructure to support it is typically built out by the customer. It might be something on S3, it might be something physical, but Alluxio is only providing software.
Great. Next one here we have is, what object protocol are we supporting? For example, do we support CSV, Parquet, or S3 Select?
So those are three slightly different things in terms of CSV and Parquet. Alluxio is generally going to be fairly agnostic to the type of data. We connect to different storage systems, like an object store or an HDFS data lake. So if you're storing CSV or Parquet on there, we kind of don't really care. We'll be able to access it, regardless. For something like S3 Select, that's an optimization on AWS. And if you're running in that environment, again, Alluxio is a little bit agnostic. It'll be the equivalent of a push-down optimization for the query itself, and it will function fine through Alluxio.
Great. And we also got a few questions about whether we can see a demo. We're running out of time for today, and it was not planned as part of this Tech Talk. However, we will be sending out an email post this event later today with a link to our next Tech Talk, where we will be going through a demo. So definitely stay tuned and make sure you register for that. Our next question here is, and I think Alex has already sort of touched on this, but if you could expand a bit further around what are some of Alluxio's advantages in a non-hybrid cloud configuration?
Sure, yeah. So in a non-hybrid cloud configuration, the advantages are typically speeding up a object store. And so we've talked before about things like MinIO or Ceph or Isilon. Being able to treat those like an HDFS-like storage layer in terms of performance and scale is one very clear advantage that we have seen and our customers see. The other is to be able to offload some of the work from existing HDFS data lakes. Some of these workloads scan a very large amount of I/O to do their work. And if this is going against a busy HDFS cluster, and you're able to kind of segregate it away and offload it to Alluxio, it can lead to an environment that just has a better customer experience. So those are two quick ways that we can help in a non-hybrid environment.
Great. Our next question here is for the compute data caching use case for Alluxio. Would there be a dependence on the application design, whether REST-based data access or RPC-based?
So I think it depends. It depends on what the application is doing and how it's doing it. So yes, there is going to be a dependence somewhere. What I would say is that for things like Spark or Presto or TensorFlow, the way that Alluxio works is that it's able to kind of transparently insert itself in between, whatever Spark's talking to. So if Spark is fetching its data from S3 or HDFS, Alluxio is able to kind of seamlessly inject itself into that layer through a configuration property and nothing else. And so, you might be talking to Spark through REST, or you might be talking to it through RPC, but how Spark goes about talking to its data is where Alluxio can help. And so if you think about it, from that perspective, that's probably the first thing to consider.
Wonderful. And I know we're coming up to time here, so that will be our last question for today. But I do want to emphasize again that we have a community Slack channel where not only will you be able to engage with folks like Alex and Peter and our other engineers and tech folks, but you'll also be able to interact with a community of users of Spark, Presto, TensorFlow, and more. So if you have additional conversations you'd like to have or questions, please don't hesitate to join us on Slack which is alluxio.io/Slack, also posted into the chat box below. And thank you both for giving a great presentation and this Q&A session today. And I just wanted to recap also that we will be sending out an email with a recording to today's session as well as the slides. And we hope the audience will join us for our next session. So thank you guys. Thanks for joining us.